Good morning guys, Anjani Kumar here, dealing power system 2 for third year electrical students. Right? In the last session, we started a rigorous method. Right? We started what is a long transmission lines, right? How the RLC are uniformly distributed throughout the length of its line, and a circuit model representation of a long transmission line, and then the performance analysis of a long transmission line with the help of rigorous methods. Alright, so in that we consider the small part delta x. So according to that part, your resistance, inductance, capacitance, conductance will changes. Right, what are the boundary conditions? If x is equal to 0, it can treat it as a receiving end. If x is equal to L, it can treat it as a sending end. Right, so what are the two important things that we need to know? That is called propagation delay or a propagation constant. So it can be denoted by gamma, so that is called square root of yz. And second one is characteristic impedance, so that is called square root of z by y. So those are the things that we need to consider. Right, so today we will solve the equation. You just consider. So what so the simple, this delta x part I am taking, right? Right, this is called Vx, this is called Ix. X means I of x, right? So this is V of x plus delta x, right? So the current we can call it as I of x plus delta x. Hope it's clear. It is R delta x, R del x, L del x, C del x, G del x, right? So now you know the impedance, it forms a series elements. This we can call it as an impedance network. This we can call it as an admittance network. So you can replace this RL in the form of impedance. It can replace in the form of admittance. So how it will be this? So I can replace the total network like this, right? So this is called Z, this is called Y, right? So Z means del x length that you are considering, del x value, del x you consider, right? So here this is V of x plus del x, this is I of x plus del x, this is Vx, this is Ix. So whatever the current in a shunt path, we can treat it as I1. Hope it's clear, nothing is there. Alright, so where Z is equal to R plus J omega L, right? So Y is equal to G plus J omega C, right? You know the impedance which are connected in series, admittance, how it will be. Hope it's clear, right? These schematic we are representing like this for a simple manner, right? Now we'll solve the equation. Now you just apply a KVL here. So this is a plus and this is a minus. You just apply KVL, correct? So if you apply KVL, you just apply KVL, right? So whatever the plus minus voltage is there now, plus V of x plus del x is equal to, or whatever it may be, V of x plus del x is equal to Z into del x into I of x plus Vx. So loop equation, you have to note it down the equation. or else the current flow like this, right? So you can write it as minus V of x plus del x plus z del x I of x plus b of x is equal to 0. Right? Apply the loop equation, right? So plus minus. This is a minus to plus na current travels. It's a minus Vx plus del x. So what is the voltage here? And what is the voltage here? Plus and minus. Now, so V of x plus del x is equal to V of x plus z into del x I of x, right? So from this V of x plus del x minus Vx by del x is equal to I of x into z. Any doubts? Nothing is there. So V of x come this side and del x come this side. So what is the value? I of x into z. Now you apply a limit del x tends to 0. So that you are applied. So if you apply a limit del x tends to 0, this whole term is nothing but a derivative term. Right? Limit upper part by lower part, when lower part tends to 0, it's like a derivative term. If you know the limit equations, you will clearly understand. So this form will be a derivative term in terms of dv by dx is equal to z into I of x, right? This is a voltage term, the first equation, right? Nothing is there. If you apply a limit del x tends to 0, it will treat it as a derivative term. So dv by dx is equal to I of x into z. Nothing is there, right? Now I am applying a KCL here at point A. I am applying a KCL, right? So I'll write it out here. KCL at A. You will tell. So apply a KCL. So whatever the I of x plus del x entering, I1 Ix is leaving. So that means I of x plus del x is equal to I1 plus Ix. Nothing is there. Alright. So you know about I1. What is I1? This is a voltage and this is a impedance. Voltage into impedance, we can call it as a current now. So what is I1 here? I'll write it here. I1 is equal to V of x plus del x into y del x. Right? Nothing is there. What is I1? Voltage into impedance, right? So now substitute here. I of x plus del x minus I of x is equal to what is I1? V of x plus del x into y del x. Nothing is there, right? So now I am taking this I of x plus del x minus I of x by del x is equal to V of x plus del x into y. Hope it's clear, right? Now I am making that here also limit delta x tends to 0. So now the term is, so di by dx. So it is a I term now. It is a v term. That's why we make it as a dy by dx. Now it is a di by dx. So di by dx is equal to, so what is v into x plus dx? So dx is 0. That means vx into y. Right? This is a current term, equation 2. So you got voltage term, you got the current term. So you apply a voltage, you will get the dV by dx. If you apply KCL, you will get the di by dx. Nothing is there. Hope it's clear. Right. Now, so what is dV by dx? So you know that dV by dx is equal to I of x into z, and di by dx is equal to v of x into y. Right. Now here I am doing another derivative. So if you d by dx means, so how it will be d square v by dx square. Again I am derivating. So how it will be? So di by dx into z. Right. So what is di by dx? So from this you will write it down. V of x into y into z. So d square v by dx square. Right. So what is the value? D square v by dx square is equal to yz v of x. Right. You know gamma is equal to yz, square root of yz. So gamma square is equal to yz. You just apply a gamma square there. Then you will get d square v by dx square is equal to gamma square v of x. Right. In terms of gamma. Right. Gamma square v of x. Then, so from this, if you derive and whatever you do, so if you go for integration and differentiation and all this, you will find out the Vx value. So from this, how you can get the Vx is equal to A1 is a constant, e power gamma x, right, plus A2 e power minus gamma x. Right. So from, if you derive both side integration, or these two differentiations will cancel out. So from this you can calculate the value of v of x. So from that, what is the value of v of x? That is nothing but a1, a2 are constant, a1 e power gamma x plus a2 e power minus gamma x. This is one equation, very very important. Right. So from this, so if you again derive that, so dv of x by dx, so what you get? A1 e power gamma x into gamma plus A2 e power minus gamma x into minus x, minus gamma, right? Minus gamma, right? So what is the equation will be? A1 e power gamma x gamma minus A2 e power minus gamma x. So that is called dv by dx. Right. So I'll write it at here. So the continuation is, so dv by dx is equal to a1 e power gamma x into gamma minus a2 e power minus gamma x. Right. So you know the value of dv by dx, that is equal to I of x into z. So that we can replace I of x into z, that is equal to here gamma will be there. If you common the gamma, so a1 e power gamma x minus a2 e power minus gamma x. Right, so from that I of x is equal to gamma by z a1 e power gamma x minus a2 e power minus gamma x. Right, so what is the value of gamma? Gamma is equal to square root of yz. So what is the value of z? So from this, gamma by z is equal to square root of yz by z. Right, so you can write it as square root of yz by z means square root of yz by square z into square z cancel. You will know y by z, so that we can call it as a 1 by zc. Right, so gamma by z is equal to 1 by zc. We just substitute gamma by z over I of x. So I'll write it out here. So we got the equation I of x is equal to gamma by z a1 e power gamma x minus a2 e power minus gamma x. Right, so you know that gamma by z is equal to 1 by zc. Right, so I of x is equal to gamma by z is nothing but 1 by zc into a1 e power gamma x minus a2 e power minus gamma x. Right, so from this you got the equation for I of x. Right, now use a boundary condition at x is equal to 0. So that means v of x is equal to vr, I of x is equal to is. Right, this is IR. I of x is equal to IR. So you know the value of Ix. So from last derivation, you know the value of Vx. So what is the value of Vx? So from here, you know the value of Vx also. Substitute. Right. So you know the value of Ix. You know the value of V of x. That is nothing but what is the value of Vx. So that is A1. So that is called A1 e power gamma x plus A2 e power minus gamma x. So you know the value of I of x, you know the value of V of x. Now use a boundary condition. If x is equal to 0, it's a receiving end sign, na? V of x is equal to VR, I of x is equal to IR. Now substitute. Then you will get, first I'll use a Vx. Right, so Vx is equal to Vr, so that you will get a boundary condition. Vx is equal to Vr is equal to a e power 0 1 na a1 plus a2. Right, I hope it's clear. All right, now what about Ix? So from Ix is equal to IR na, so from this you will get a IR ZC is equal to ZC, it will go there. IR ZC is equal to A1 minus A2. Right, so A1 minus A2. So from this you will know that A1 is equal to, so VR plus IR ZC by 2. A2 is equal to VR minus IR ZC by 2. Now you got a A1, A2, substitute, you will get the result. Right, first we will go for a Vx. Right, so from this, so what is a Vx value? So Vx is equal to right? A1 into e power gamma x, right? So what is A1? So VR plus IR ZC by 2 e power gamma x plus A2. What is A2? VR minus IR ZC by 2 into e power minus gamma x, right? So from this, if you common VR first, then you will get e power gamma x plus e power minus gamma x by 2, right? Then you will common IRZC, right? So IRZC plus IRZC. If you common IRZC, you will get e power gamma x minus e power minus gamma x by 2. Hope it's clear, right? So e power gamma x plus e power minus gamma x, it's nothing but a hyperbolic function. So how you can write it as VR cos h gamma x, right? So here I'll write out e power gamma x plus e power minus gamma x by 2. We can call it as a cos h gamma x. If it is a minus, it will act as a sign. So from this you will get it as IR ZC sin h gamma x, right? So that is called Vx, right? Now you started at x is equal to L. X is equal to L. So what is Vx? Is equal to Vs. Ix is equal to Is. So then substitute. What is Vx? So Vx is nothing but Vs is equal to VR cos h gamma x is equal to L plus IR ZC sin h gamma L, right? So you got the formula, right? So you got the formula in terms of Vs is equal to AVR plus BIR, right? So this is called A value, this is called a B value, right? So you got a parameters of A and B, right? So at x is equal to L, you substitute Vx is equal to Vs, Ix is equal to Is. Now you got the value of Vs is equal to VR cos h comma L, IR ZC sin h comma L. So you got AB value. I'll write it out here. Then substitute Ix, then you'll get value of C and D. Right? So what is the formula? So Vs is equal to VR cos h gamma L plus IR ZC sin h gamma L. So you got the value of A and B. So one type of equation you got. Alright. Now you just substitute in the form of Ix. So you know value of Ix. So Ix is equal to 1 by ZC A1 e power gamma x minus A2 e power minus gamma x. Right? So you know the value of A1. So A1 is equal to VR plus IR ZC by 2. So A2 is equal to VR minus IR ZC by 2. ఇంతకుముందు Vxలో సబ్స్టిట్యూట్ చేసావు, ఇప్పుడు Ixలో సబ్స్టిట్యూట్ చేస్తున్నావు. Alright. So what is Ix is equal to 1 by ZC. So what is A1? VR plus IR ZC by 2 e power gamma x minus VR minus IR ZC by 2 e power minus gamma x. Hope it's clear. Right? Right? So from this, so VR VR common this on go. VR here you will get VR by ZC. Here must VR common this is so e power gamma x minus is there na minus e power minus gamma x by 2. Right. So and here you will common plus I or ZC plus I or ZC. One more ZC is there na. So u power gamma x plus e power minus gamma x by 2. Nothing is there. Simple mathematical calculations, right? ZC just get cancelled. Now what is this win? So VR by ZC, right? So you can call it as a sine h gamma x, right? So this we can call it as a IR cos h gamma x ix, right? Now substitute x tends to L, so then ix is equal to is, right? Then substitute, it is is equal to VR by ZC sine h comma x plus to L plus IR cos h comma L, right? So this is in the form of is equal to CVR plus DIR, alright? So this is called C value and this is called a D value. Hope it's clear. I'll write out both the equation Vs and Is. With that we can estimate the value of ABCD, right? So Vs is equal to, so VR cos h comma L plus IR ZC sine h comma L. Is is equal to so VR by ZC sine h gamma L plus IR cos h comma L. So now write out the ABCD parameters, right? So this is called A, B, C, B. That means in the form of Vs is equal to AVR plus BIR. Is is equal to CVR plus DIR. Hope it's clear. Now we'll solve. So Vs, VR. So what is the value of A? Cos h gamma L. ZC sine h gamma L. C value 1 by ZC sine h gamma L cos h gamma L, right? If you calculated A is equal to D and AD minus BC is equal to 1, right? So if you want to cross verifications, right? So VR, this is IR. So this is the rigorous method to solve the ABCD constant of a long transmission line, right? So this is a simple mathematical calculations that there are assumptions. What are the assumptions that you are taking? Where gamma is nothing but propagation delay, so that is root of yz, where ZC is nothing but characteristic impedance, so that is called Z by Y, so that is called characteristic impedance, right? So where L is the length of the line, right? So in this way we solve the ABCD parameters of a long transmission line with the help of a Regarous method. So I think you have to see one more time the video. Definitely it will be clearly understand, right? If you got any problem while while seeing this video, feel free to call me. I'll clearly explain the total concept. Alright, I hope it's clear. So this is the relationship. So this is the ABCD constants of a long transmission line. Right. This is up to now. In the next session, we'll discuss about how the long transmission line can be represented with the help of nominal T method and nominal pi method also. Thank you for now.